Okay, this is a supplemental lecture that talks about processes on Unix and Linux operating system. So basically, a program that is running equates to a process. And there is information about that process referred to as metadata, and that are things that can be used as evidence. There's several things that we would want to track. The process ID, which is a unique identifier that identifies the process to the operating system. There is a parent process ID called a PPID, and that is who launched it or what process launched it. In Unix, you have a function called fork, and processes are created by forking a process that's running and changing it to something else, and then it continues executing under whatever that new thing is. We have a user or a UID, a user being the name like Wayne, UID being the unique number that identifies the user, and that is who owns the process. Unix also tracks when the process started and the total amount of CPU time that is being used, and then, of course, the command that is being run. Other things, you have a TTY, which is the terminal it's running on. Is it running interacting with a user, or is it running in the background like a daemon? What percentage of the CPU is it using currently? What percentage of memory is it using currently? And then something that's listed as stat, which is an abbreviation for state. That's the process state, and the process state can have several values: R for running, S for sleeping, Z for a zombie process, and T is the process still exists but is currently not receiving any CPU time, which is called stop. There are also some modifiers to process state that I didn't think it was important to talk about right now. Now, when a Unix machine starts, the very first process is referred to as init. Init always has a process ID of 1 and a parent process of 0 because nobody started it. Like I mentioned earlier, processes are created with a call to the fork function. And here's an example of a process tree. We haven't talked about it yet in great detail, but this is the output of the PS command with the -- forced option, and it kind of gives you a hierarchy. For example, init started running, and then init spawned secure shell D, which is me logging into the machine. It spawned a specific SSHD for me on TTY PTS/0. It's running the bash shell, and within that bash shell, I issued the PS-EF -- forced. So that shows the parent-child relationship and the tree of processes that are created. So I primarily did this to show you the metadata and a little bit about what -- forced does. And like I said, that was created with this command that we saw at the top. Not all PSs have a -- forced option, unfortunately. And if your operating system doesn't have it, for example, it's Mac OS, you can install PS-Tree to get the same thing. I did that on my Mac, and here's a little bit of the output. So similar, but not exactly the same as what we saw with it built into the PS command, but you still get a tree or a trail of how the processes came into existence. I'm going to show you some examples. This is a basic PS command, and what I mean by basic PS command is you issue the PS command with no options, And if you do that, that will give you the output of your jobs that you are currently running. Now, this machine has hundreds of processes running on it, but these are just the ones that belong to me and what's running and what TTY they're on. If we wanted to know how many processes are running, as I mentioned a minute ago, there's probably hundreds on this machine. You can pipe the output of the PS command into word count and use the -L option to tell it we only care about the number of lines. And when we do that, we get 867. So that's how many processes were running on my laptop when I was making this presentation. If we want to list all the processes and we care about seeing the parent process ID, we can do that by adding -EF. And when we do that, we will get output that looks like this. So we have the UID, the numeric value of the user that's running it. 0 is root. It shows the process ID, and then it shows the parent. So on this screen, since it's a Mac and it is called LaunchD, so LaunchD started, and then it started all the processes that are at least shown on this screen. And there are 855 processes that I didn't show. The next example is, what if I want to search by process by the user that the process is running as? And the way we do that is by using the -U for user option on the PS command. So this command would say, show me all the processes that are running, that are being run by the processor owned by, the user, www. And the output would look like this. So, this has one process. There's the command that's being run. The question mark in the TTY column means that it is running in the background, not associated with a TTY. What if we want to look for suspicious processes? What suspicious process is can vary, but in this case, we're doing an expression grep of all the output, the PSAUX, and we're looking for INC running, we're looking for all the shells that are running, and we're looking for things that Python and Perl may be running. So these could be legitimate processes, but suspicious processes often run with one of these commands. And the output we would get would be a potential list of suspicious processes that you would then need to go through and look at and decide if they're legitimate or suspicious. What about processes that are running without a terminal? We can do that by grepping or searching for things that have a question mark in them, because we saw previously that you have question mark for things that are not associated with a terminal. Now, there's many legitimate processes that would be true for, but when I ran this, here are some things you see. Init is legitimate. Cron is legitimate. Somebody secure shelling into root, maybe that's you. If it's not, you need to investigate. We have Apache running. But on the next line, notice that the command, first glance, may look legit, but instead of running SSHD, it's running .sshd, trying to look like a legitimate process. So some of the ones that follow are not legitimate processes. But that's how you find things that are not associated with a terminal. So we've already talked about the .sshd. Here we have something, in addition to running out of temp, is running out of a hidden directory, .x. Again, any directory or file that starts with a period on a Unix machine by default is hidden from like the PS command. You have to tell it you want a full listing to get that. Or if you were going around looking at LS and temp, you wouldn't see this unless you use the -A option. Down here, we have something run .cron.sh. Well, the .cron is suspicious. The .sh on the end is because if you look up at the second line, cron just runs as cron, not a shell script. Here we have something running out of the device directory. It is hidden, and it is a Python script. And those are things that could be considered suspicious. Sometimes, either because it could be a malicious piece of software running, or you may have a runaway process and your machine's being low. So you might want to look at things that are sorted by CPU utilization and then decide if there's a problem or if your machine is just legitimately busy. So we use the PSAU command to give me all the processes. We then sort in reverse numeric order. The K is for column. We want to sort on column 3 to column 3, which is just column 3. And then we want to pipe that to head -5, which will give me the top 5 lines of output, which will equate to the top 5 running processes. So when we do this, this is what we get. Notice that Media Analysis D is eating 85% of the CPU when this command is issued, followed by about 20% for Homebridge. So if you didn't know what these things were, you might want to look at the Unix man pages or possibly do a search on your favorite search engine to figure out if these are legitimate processes or not. We can do the same thing, sorting by memory utilization. That is column 4. So the only thing different here is instead of sorting on column 3 like we did in the previous example, we're sorting on column 4. And the output would be this. So there's something called KSWAPD0 running as a root, consuming 61% of the memory. And then we have a Python program below that using about 9% of memory. So we might want to investigate some of these processes to see if they are legitimate or not. Now, sometimes when we issue the PS command, with it trying to make it look right, it truncates the command that is running. And usually that's a relatively long path name. So if we wanted to see the entire command, we do that by adding the WW option. W means wide, WW means something like really wide, or show me everything regardless of how wide it is. And then I want to see the top 5 commands. And when I do this, this is what I get. So instead of seeing things like Media Analysis D, I actually see the full path name of where it is running on the system. Here's an example of combining grep and grep with the -V option. Grep search for a string and displays lines that have matches. -V displays lines that do not match. So in this command, I'm saying give me a full PS list. We're looking for the netcat command, but there will be a line that will have grep on it. So I want to get rid of that line so that I only see things related to NC. I don't see my grep NC command in the output. So when I do that, this is what I would get. And again, it's not showing me actually issuing the grep command, looking for NC. It just shows me lines that have NC as part of them. So a very handy tool to get rid of extraneous output. This is more what I'm calling our forensics view, What are some of the top things we care about? We care about who the process is running as. We care about the process ID, the parent process ID, when did it start, and what TTY is it running on, followed by percent CPU, percent memory, and the actual command that's running. One note, some Unixes list commands as CMD, but things like the Mac issue it as COMM. So you want to make sure you have the right option there. Or if the command's not showing up, it's because it's slightly different. And then I want to sort this in reverse numeric order. And the output will be this. So these are kind of the key pieces of metadata or process information you might need in an investigation. If we have one process we want to focus on, PS has a P option that allows you to specify a process ID. For example, in this case, 35959, and the output will look like this. It will only have the line of output that happens to correspond to Keynote, the presentation software that I use on this machine. Now, another super handy command is LSOF. One of the things that we can do is we can give it a process ID number and tell it to show all the files you have open. So I'm looking at the same process that I used the PS command on and searched for before. But here I'm saying, show me information about this process. And it gave me about 600 lines of information. Here's the top few lines. So this has lots of files open, and it will tell me what all those files are. Another thing we might care about is network connectivity or connections tied to a particular process ID. And we can use the LSOF-I command, and the output will look like this. So it will tell me what type of connection it has open, the protocol, etc. If we want to know what processes are listening on a port, I think I've used this as an example before. On my Mac, occasionally process 1025 pops up, and by default, originally, it was referred to as the blackjack port. So when I do the output, that's why it's going to say blackjack. That's the actual port number. If I added the N option, instead of putting blackjack, it would put the 1025. And it tells what connections that process has to the internet. That's what the -I is for. And it could be IP:/port. If you just say :port, then it looks for any process that is connected on that port. If we care about network activity for a specific process, we can use the -P and give a process ID. And when we do that, we would get output that looks like this. So we have something called RapPort-D, which is running, has established connections, but is also listening. So it was listening, something connected to it. It looks like it was my iPad connected to it, and then it showed the established connection. But the main daemons keep listening for other connections. Sometimes a way to hide software, this has been true for decades, is by getting it in memory, getting it running, and then deleting the file that it was running from to try to hide the process. So if we run LSOF to show all the open files on the systems, but then we search for the word deleted, we will get output that looks like this. So in addition to them running from a file that's resident in memory, not from a file that still exists. That's suspicious in itself. And then we can see other things too, like things running as .httpd instead of httpd. If we want to know for some reason what has a specific file open, for example, we see host.data, what process has that open? We can give the file name or the path name to LSOF, and this tells me there's a Perl script running. This is my Network Watcher program that I've shown you before. It's running as root, and it gives me the process ID of that process. And it also tells me that Perl is the command that's being used to run this. Things running out of the temp directory a lot of times are suspicious. With LSOF, you can give it the +D command and then a directory. So that's what the +D means. Show me anything that is open out of the temp directory. And this is the output we get. Now some of these, actually all of these look legit. But if you saw something that looks suspicious, you might want to dive in a little closer and see if you can figure out what's going on. There is something called the kill command, and there are common signals that you send with the kill command. Depending on the OS, when you look at the kill command, it will either say send a process or terminate a process. More accurate is send a process. So signals have numbers and names, and what I'm doing here is showing you some of them. It's not an all-inclusive list, but it is the more common signals that you might send and what they mean. Now, a signal of 1 is a HUP or a hang-up, and that is the signal that is sent to a process under normal operations originally when their terminal disconnected for some reason. These days, a lot of processes, it means I changed the configuration file. I want you to continue running, but read your new configuration and start using that new configuration. The next one I want to talk about is signal 2, which is an interrupt. If you use it symbolically, it's INT, and that means you interrupted a process by doing a Control-C. So maybe that was in an infinite loop and you need to break out of that infinite loop. The next is quit, which is 3. You get a quit by doing a Control \. These processes, before I talk about the next one I'm going to show you, let's go back to process 1. Process 1, the process kept running and possibly reread a configuration file. However, you can also set it up and say, if I get a hang-up signal, I want to ignore it. So most of these signals can be ignored if you have the code in your program to do so. Now, signal 9 is a kill. This is a non-catchable, non-ignorable, die right now. So the process will not do clean termination or anything like that. And the only thing that it cannot kill is a zombie. And we'll talk about zombie processes later. 15 is terminate. This is a graceful shutdown. Hey, I'd like you to go away, but I'm going to give you time to close files, flush buffers, write messages to the log that you're terminating, etc. So, basically, please go away, but I'll give you time to clean up. 18 is a continue. If you have a stop, which I don't know why stop didn't come first, the continue does, but anyway, if a process is stopped and not consuming resources, and you signal the continue signal, it will start using CPU time and start continuing to execute. If you want a process to stop, You can use 19. This is another non-ignorable signal. You will stop receiving CPU time immediately. There's something called T-stop, which is doing a Control Z. So if you have a process running, but you need to do something else, you can do a Control Z to stop it. And then when you're ready for it to continue, you can either use the kill signal, or not, you can use kill to send a continue signal, is the most common way that you would do that to start the process back up. So using an example of telling HTTPD to read its config file. So you have a HTTPD process running. You may actually have multiple ones, so you need to find the original one that is running, the one that is spawning more HTTP daemons to process web connections. But to the main HTTP process, whatever its process ID is, you send a HUP signal to it. And there will be no output to the terminal. You just have to trust that it reread the config file. Now, there's no output to the terminal. However, it does issue a write to the error log that says, hey, I just got a SIGHUP signal. I'm restarting, which will cause it to read the new configuration file. If you have a suspicious process and you don't want it to continue processing it, then you'll do a kill-9 or a kill-kill to kill that process. There will be no output generated. So that finishes up this supplemental topic on processes and a number of examples using PS related to processes and using LSOF related to processes.